In this video, we're going to calculate the second moment of area for an I-beam section. So in this example, we're going to calculate the second moment of area for the I-beam plotted on the coordinate system. So in this example, all dimensions are in meters. Because the shape is doubly symmetric, the centroid is located exactly at the center of the web at coordinates 0, 2.5. So we're going to solve this using two different methods. The first method is an additive method. So we're going to solve this by decomposing the I-beam into three simple rectangles: the top flange, the central web, and the bottom flange. So for each segment, we find its local inertia, Ix prime, its area, A, and the distance dy from its own center to the overall centroid. So using the parallel axis theorem, we calculate Ix to find the inertia relative to the beam's overall neutral axis. So starting with the top flange, we calculate the local inertia for the rectangle is 6 meters wide by 1 meter high. So applying the formula, the base times height cubed over 12, we have 6 times 1 cubed over 12, which is 0.5 meters fourth. We can calculate the area, so 6 by 1 is 6 meters squared, and the distance dy is the distance from its centroid, which is at a height of 4.5, to the centroid of the overall shape at 2.5, so 4.5 minus 2.5 is 2 meters. So applying the formula to find Ix is equal to Ix prime plus A times dy squared. So we have 0.5 plus 6 times 2 squared, which is 24.5 meters fourth. Moving to the middle rectangle, so we calculate the local inertia. So the base is 2 times by the height, which is 3 cubed over 12, gives us 4.5 meters fourth. Its area is 2 by 3, which is 6 meters squared, and the dy, so this rectangle shares its centroid with the overall shape, so dy is 0. Therefore, Ix is equal to Ix prime, which is 4.5 meters fourth. Moving to the bottom flange, so applying the same formulas, so calculate its local inertia. So the base is 6 times by the height, which is 1 cubed, divided by 12 gives us 0.5 meters fourth. Its area is 6 times 1, which is 6 meters squared, and dy, so its centroid is at a y-coordinate of 0.5, so the 0.5 minus the 2.5 for the overall centroid is minus 2. So to calculate Ix, we use the formula of the parallel axis theorem, which is 0.5 plus 6 times the minus 2 squared is 24.5 meters fourth. Find the inertia for the overall shape. We take the sum of the Ix's, 24.5 plus 4.5 plus 24.5 is 53.5 meters fourth. So there's sometimes a faster way to solve this, and we're going to do this using the subtractive method instead. So instead of adding three smaller shapes, we can look at the envelope of the beam. So we can imagine a large solid rectangle that covers the entire width and height of the beam, and then we can subtract the empty space, the two cutouts on either side of the web. First, we calculate the inertia for the large bounding rectangle, then we subtract the inertia of the left and the right cutouts. Since all three of these rectangles share the same horizontal centroid axis as the main beam, the distance dy is 0 for every part. So in practice, this eliminates the need for the parallel axis theorem entirely. In this example, I'm going to complete the table as I did before. So starting with that large rectangle, we calculate Ix prime. So the base is 6 times by the height, which is 5 to the power 3, and we divide by 12. This gives us 62.5 meters fourth. Its area is going to be the 6 by 5, which is 30 meters squared. As we already said, the centroid is at the same height as the centroid for the overall shape, so dy is 0. So in this case, Ix is equal to Ix prime, which is 62.5 meters fourth. So moving to that left cutout, we can calculate Ix prime. So using the formula, the base is 2 times by the height, which is 3 cubed, divided by 12 is 4.5 meters fourth. The area is 2 times 3, which is 6 meters squared. As we said, dy is 0. So Ix is going to be 4.5. So here I'm going to record this as minus 4.5 because I'm going to be subtracting this from the larger shape. Then for the right cutout, I can use the formula to calculate Ix prime. So this is the same shape as the left cutout, so it's also 4.5 meters fourth. Its area is also 6. dy is also going to be 0 because it's at the same height. Therefore, the Ix is 4.5 meters fourth. Again, recording it as minus 4.5 because I'm going to subtract this as well from the larger rectangle. Now I can take the sum of the Ix's. So 62.5 minus 4.5 minus 4.5 gives us a total inertia of 53.5 meters fourth. So whether you add the segments together or subtract the voids, the result is the same. So you can choose the method that makes your geometry the simplest to calculate for the example.